Welcome back to Math with Patrick. Today is March 6th. This is the 65th problem of the year. We're going to solve it together today. So y, a variable, is equal to all of these things being added up. It's a whole bunch of whole numbers, and they all have this power of -1 on them. And finally, when I find this value for y, I'm going to multiply it by 7 and get x. And the goal here is to solve for x, and it's supposed to be 6, which is today's date. So I guess here's my goal. I am just going to do all of this arithmetic. I'll finally multiply it by 7, and I want to get 6. And if you notice all of these exponents, they're all -1. And so let's talk a little bit about what it means to raise a number to a negative number, or a negative power, rather. And let's start with this 2. I feel like 2 is a good example. So if we talk about exponents just basically mean repeated multiplication. So let's even start with 2 cubed first. Why not? 2 cubed is the same as 2 times 2 times 2. I'm repeating my base the same amount of times as my exponent. And if you do that multiplication, you get 8. 2 squared has 2 copies of 2. That is a 4. 2 to the power of 1 has, well, 1 copy of 2. And then you're just going to get a 2 out of it. So it gets a little strange when you raise things to the power of 0. And one way that you can confirm what this number should be is just by following the pattern of the previous numbers. So we have a 2, a 4, and an 8. And if we go this way in our pattern, all we're really doing is tacking on another 2 with multiplication. And so going this way in the pattern, the next number this way should be 16. And I mean, that is the same as 2 to the 4. It is the same as multiplying all these 2's together. It's just one more multiplication of 2. So if you think about it the other way, if we go left in this pattern, we're actually just dividing by 2 instead. It's just the opposite of multiplying by 2. So divide by 2, divide by 2, divide by 2 gets you to the next number in the list. So even though we have no 2's right here, there's just kind of nothing going on right there, the right number to put here is 1. Because if you imagine that pattern of multiplying by 2, well, if we go to the left, we are dividing by 2. And, well, following this exponent pattern, 4, 3, 2, 1, 0, it makes sense why -1 would be the next, because we're just counting down. And here we could just follow the same rule of dividing by 2 to move left in our pattern. And 1 divided by 2 is a half. It basically, by definition, is, I guess, because this says take one part and split it in 2. The number half is just the same as 1 divided by 2. And if you notice, basically all I did when I had this power of -1 is I just stuck the 2 in the denominator. This is going to be the same for 6 to the power of -1, 12 to the power of -1, all of these to the power, anything to the power of -1. I'll just write that as a nice rule here. A to the power of -1 is going to be equal to 1 over a. And then just as an aside for other negative exponents, if you want, a to the -b is going to be the same as 1 over a to the b. So technically there is going to be a 1 right here, and all that really happens to this exponent is that the negative sign gets removed. It doesn't go away entirely, right? Because in this example, you can see that the exponent stays, just the negative sign is removed. But as we kind of saw here, anything to the power of 1 is just itself. That's what happened to this 2 right here. And so you could be pretty confident that's going to happen to all the other numbers in this long sum. So let's write it all out. Y is equal to, instead of 2 to the power of -1, I will write 1/2 plus 1/6 plus 1/12 plus 1/20 plus 1/30 and plus 1/42, or 1 over 42. And this is my number y. Hopefully when I multiply it by 7 later, I'll get 6, today's date. And, well, when you're adding fractions, usually the best strategy is to find the least common multiple to get a nice common denominator going. And what I mean by that is like you can count your multiples of 6, like 6, 12, 18, 24. You can count multiples of 20, which would be 20, 40, 60, 80. And you have to do that basically for all of these numbers. And the first number that you find that they all line up on, that's the new denominator that you should choose to add these all up together. So I notice that if I count by my multiples of 2, I will hit 6. 2, 4, 6, 8, 10, etc. And so if I'm counting by my multiples of 2, it's like for this common denominator, I really only need to count by my multiples of 6 because that covers the 2. Same thing with the 6 and 12, actually. If I count by my multiples of 6, I will encounter all of the multiples of 12. So already I know that my least common multiple, or my new common denominator, has to include a 12. And let's see. So it also needs to agree with this 20 and 30. And let's see. What new factors am I introducing here? So 12 is the same as 4 times 3, or 2 times 2 times 3. And if I break down the 20, it's like a 10 and a 2, or let's see, it's 2 times 2 times 5. 30 is going to be 3 times 2 times 5. So notice how 12 already had 2 2's. So these 2 2's are already covered, but I need to include a 5 right here to find the next least common multiple. This is kind of the strategy for finding them, is you just like grab the fewest number of prime factors possible, and that will create your least common multiple. So I already have 2 2's and now a 5. And then I already have a 3, a 2, and a 5 in here. So I don't even need to consider this 30. And then lastly, in the 42, I am going to find its prime factors and include anything new that I don't already have here. 42 is 6 times 7. That 6 is already represented here with the 2 times 3. This 7 is a new factor, and so I will include it in my list. And so I know that I have just found my least common multiple, which will be the best common denominator for all of these fractions. Okay. Let's see. Well, 2 times 2 times 3 was 12. And then 5 times 7 is 35. And so doing this multiplication really quickly, well, that is 350 plus 70. So I'll do 420. Cool. So all of these deserve a 420 in the denominator. And now I need to choose the correct numerators before I add them all up. And I'll just kind of do it in whatever order feels easiest to me. Like, for example, the 1/2 isn't too hard. I know that half of 420 is going to be 210. The 420 here, let me put an arrow to that just to show where this whole thing's coming from. The 420 off to the side isn't too hard. If I multiply 42 by 10, I get 420. So this should be a 10. Now it gets a little bit harder. Let's see. A sixth is a third of a half, right? Yeah. So I could reduce this down to a third of itself. So 70 makes sense. Oh, also, yeah, 42 divided by 7 is 6. So I kind of see that fact family there. Let's see. If I think about it in reverse, 420 over 20 is going to be 21. So I can kind of use that same fact family here and say that I should put a 21 there, I believe. And I'll just keep doing this until I figure out all the numbers I need to put. Maybe I'll do some division here. So I'll ask how many times does 12 fit into 420. Let's see, that will be 3, 36. Do my little subtract step. That's going to be a 60, and okay, 35. And the whole goal of finding this least common multiple for my common denominator is to get these whole number results in my numerator. Technically, you could do any denominator you want, but then you wouldn't have these whole numbers in the numerator. And it'd be like kind of hard to figure out what these numerators should be. Let's see. Okay, so this one would be easier if I just did 42 divided by 3, and then just kind of doing that long division step. It's a 14. Okay, so here are all of my fractions. And now that they have a common denominator, I can add them all up. I don't really think there's an easy way to, maybe I'll do all these ones and then add 210 at the end. So 210 plus, then I see a 105, 106, 126, 136, 140, 150. Okay, so all of those were 150 together. Adding these up, I get 360. Oh, so y is equal to 360 over 420. And then just doing some fraction simplifications. You should probably reduce your fraction before you start trying to multiply it by some other stuff. Let's reduce it by finding some factors. So I know that 360 rather, is 6 times 6 times 10. Here's the 36. This tacks on a 0. And then 420 is going to be 6 times 7 times 10. And then here, if you have a fraction, you have factors, and they repeat themselves on the top and bottom. You can cross them out to simplify, and we get y is just equal to 6/7, which is lovely because since x is 7 times 6/7, that shows us that x is 6. And that is today's date. So there we go. All of this fraction math boils down to just the number 6. So hope you enjoyed. Hope you learned something maybe new or just kind of confirming what you already know about fractions. So thanks for coming along and solving this with me, and I'll see you tomorrow. All right.